Good morning and welcome to this Conservation Applied Research and Development, or CARD webinar, which is going to report on the findings of a CARD project that investigated the energy savings potential of networked lighting systems in small businesses. Thanks so much for joining us. I am Mary Sue Lobenstein and I'm the Research Planning Director at the Minnesota Department of Commerce, Division of Energy Resources. In that role, I identify and analyze gaps within utility conservation improvement programs and coordinate and plan research to fill those gaps. The CARD program is a major tool of that work. With me today is Adoy Day, who is a public utilities rate analyst for the Energy and Rates Planning Unit at the department. Adoy provides technical support and testifies for positions of the department on rate design, rate of return, cost recovery methods and policies, energy conservation resource planning, forecasting, renewable energy, and other issues of complex gas and electric utility matters that are before the Public Utilities Commission. He was the project manager on the study that is the subject of today's webinar, and he'll be moderating the Q&A question portion of the program. Our presenter today is Joe Plummer, a program manager and energy engineer at Franklin Energy in St. Paul. Joe manages several programs for Minnesota utilities, including small business direct install programs and facility turnkey efficiency programs. Joe also provides technical support for Franklin clients, including energy audits, custom rebate analysis, M&V services, and deemed savings updates. Welcome, Joe. We look forward to your presentation today. Before we start, I'll just review a few webinar basics that should be familiar to most of you at this point, but all attendees will be in listen-only mode. We will answer all questions at the end of the presentation, but as questions occur to you, please type them into the Q&A box and send them to all panelists. We'll do our best to answer all questions within the time allocated, but if we don't get to some, we'll answer your questions after the webinar. This webinar is being recorded and will be available on the department website. The slide set from the webinar will also be available. This webinar is one in an ongoing series that are designed to summarize results from research projects that are funded by Minnesota's Applied Research and Development Fund, which was established in the Next Generation Energy Act of 2007. The purpose of the fund is to help Minnesota utilities achieve their energy savings goal. About $2.6 million is set aside annually for the CARD program, which awards research grants in a competitive request for proposal process. Results from CARD projects provide utilities with data to enhance energy efficiency program designs within their conservation improvement portfolios. As you can see by this pie chart, CARD projects funded to date have been in all building sectors, as well as some that cross multiple sectors. The subject of today's webinar is the commercial sector, and we'll discuss the performance results from real-world networked lighting projects in 4 small businesses of different types spread across Minnesota. Now I'll turn it over to Joe to start today's presentation.
All right, thank you so much, Mary Sue. Good morning, everyone. Thanks for being here today. I'm excited to be here to talk about our CARD research on networked lighting controls in small business. For the agenda today, I'm going to begin with an overview of the technology and then get into the project itself, which had 2 main components: educational seminars and then case studies of actual projects in small business. I'll conclude with some discussion and recommendations for how utilities can address the technology with an eye towards small business in particular. Network lighting controls, or NLC, is an emerging technology within the Internet of Things ecosphere. The reason we propose this project is the high energy savings potential for this technology. This chart from a report by Design Lights Consortium illustrates this point. As you can see, the energy savings potential for commercial lighting without NLC would peak in 2021 or 2022 and continue declining through 2035. However, with aggressive utility support for network lighting controls, much of this decline can be offset. This is because because traditional lighting has traditionally accounted for a large portion of electric utility savings through SIP. The high energy savings potential of network lighting controls is why we proposed this grant. However, we wanted to focus on the small business sector because much of the research on NLC and applications to date have been in large facilities and large businesses or institutions such as universities. Therefore, we wanted to focus on the energy savings potential and value proposition for small businesses. Before getting into the specifics of this project, I wanted to give a brief overview of the technology and its capabilities. Automated lighting controls such as occupancy sensors, photocells, and timers have been around for decades. Typically, they take the form of standalone devices that are hardwired to a group of fixtures or wired to a relay panel. Typically, only one control strategy can be implemented per zone, such as occupancy sensing or daylight harvesting. What is innovative about network lighting controls is that it enables multiple control strategies to be layered in the same space, which leads to deep energy savings. This is illustrated in the following charts. Think of each bar as 1 hour in a typical day. Before any controls are applied, a hypothetical room has the baseline power profile shown here on a typical day. The first strategy that can be applied is high-end trim, which simply means lowering the maximum output of the fixtures, typically to 70 or 80%. This is an easy way to generate savings with NLC systems, as energy use is directly proportional to the output percentage, and the human eye cannot detect decreases of 20 to 30%. The next strategy is occupancy sensing, which automatically shuts off lights when not needed, reducing the operating hours as shown here. The final strategy in this example is daylighting. Here, enough daylight enters the space in the afternoon hours that light output is decreased and then eventually fully shut off. After applying the combined strategies in this space, the end result is shown here. Now for the technology itself. A typical lighting control network looks like this. A central hub mounted on the ceiling serves as a link between the edge devices. Manual controls, sensors, fixture controllers, and in this example, plug load controllers. And the user interface, which is typically accessed via a smartphone or a PC. The digital network can be wired, wireless, or a hybrid. Most facilities probably use wireless, but wired networks can be used when security is a major concern. This illustration also provides examples of integration with other systems. On the lower left, plug load controllers are shown. The newest energy codes require plug load controls in certain spaces like closed offices and computer labs, and utilizing lighting occupancy sensors is one way to accomplish that. In addition, NLC systems can link with BACnet, a common communication protocol for building automation systems, to provide integration with other building systems such as HVAC. One example is leveraging occupancy sensors to control ventilation. This diagram also shows integration with utility demand response programs. Many NLC systems have this capability. Basically, it would allow buildings to automatically dim certain fixtures in response to a demand response signal from the utility. To my knowledge, however, demand response functionality has not been widely deployed to date. So many of you on the call are familiar with Design Lights Consortium. It's a nonprofit organization that works to develop performance standards for solid-state lighting. In recent years, it has developed an initiative for networked lighting controls that includes field studies, development of technical standards, and maintaining a qualified products list. Under the current technical requirements, version 5.0, NLC systems must meet the minimum qualifications listed here to be DLC qualified. Many utility programs require a DLC certification in order to qualify for incentives. I've already discussed the first 4 bullets listed here, but I can briefly cover the remainder. Zoning means that luminaires can be grouped and linked to a certain control through the software. The simplest example is programming all of the luminaires in a room to be linked to a wall switch. Another example might be setting setting up one group of fixtures in a room that is left on during business hours and another that are controlled by occupancy sensors. Individual addressability is a key aspect of network lighting controls. It means that each device in a network, including luminaires, sensors, and controllers, has a unique identifier. This allows for configuration and reconfiguration of devices and control zones without requiring electrical rewiring. Continuous dimming means there is sufficient resolution in the dimming controls, 100 or more steps, such that dimming is perceived as continuous. This allows lighting output to be finely tuned according to daylight levels or personal preferences, in contrast with step dimming, which involves a small number of discrete output levels. Cybersecurity means that the system contains cybersecurity safeguards that meet DLC specifications. This is an important reason to choose DLC-qualified network lighting controls. Finally, energy monitoring means that the system includes the ability to monitor and display the energy consumption of the luminaires in the network. Some utilities have leveraged this capability for measurement and verification purposes, or for performance-based incentives, which encourage the persistence of control settings. More advanced NLC systems include additional capabilities, some of which are listed here. I will pause for a moment to let you review the text. Many of these features add complexity and, of course, cost. The features that are most applicable to the small business segment are arguably security lighting and fault detection. As an example of the security strategy, one example is a car dealer programming their car lot lighting to switch groups of luminaires to full brightness in the vicinity of where motion is detected in order to deter vandalism and theft. Fault detection is desirable as a means to monitor emergency lighting fixtures, and NLC systems with this capability can proactively send notifications when faults are detected. Now on to the grant project specifically. The first part of the grant was to organize educational seminars in Greater Minnesota, where adoption and awareness of NLC technology was thought to be lower than in the Twin Cities, where Xcel Energy had been promoting the technology through its prescriptive incentive offer and trade ally events. Working with our utility partners for this project, we selected Bemidji and Rochester for the events. For the main presenter, we reached out to an industry partner, Robbie Perrick of RAB Lighting. Perrick was the ideal presenter because his background was in energy efficiency programming before he joined RAB. And working for a lighting and controls company, he was also an expert on the technology. Perrick gave a brand neutral overview of NLC technology at each seminar, covering its capabilities, how to make an informed purchasing decision, and ideal applications for it. Following a Q&A session, I briefly polled the audience for their thoughts on training needs and incentives for NLC. At that point, the formal event concluded, but folks had the opportunity to meet with a RAB representative to see a sample of physical NLC components and ask questions in more detail. The attendees at each event included utilities, end-use customers, distributors, and consultants. Unfortunately, no contractors attended, even though they were a major focus in the outreach efforts. Contractors sometimes install and configure NLC systems, and even if not, they do have an important role to play in terms of educating their customers on the technology. We were really hoping to hear their perspective on training needs and real-world installation experiences. Despite our best efforts, though, as well as perks like gift card drawings and free breakfast, we were not able to get contractors to either event. However, we did get some lively discussions at each event. I have listed some of the questions and comments that stood out from my perspective. First, questions came up around integrating NLC technology with other building systems. I can say that this is already being done to some extent. One example is using occupancy sensors to control ventilation as well as lighting. The DOE's Pacific Northwest National Laboratory recently launched an integrated lighting campaign to promote these opportunities. However, as the presenter at our event alluded to, it's not always easy and straightforward to get two different control systems to play nice with each other. Second, concerns were raised about cybersecurity. These concerns can be mitigated by purchasing DLC qualified systems, which have to meet robust cybersecurity standards. Third, the presenter made the comment that non-energy benefits are often most important to customers. A big draw for many customers is the ability to monitor and adjust their lighting system on their phones, just like so many other things that we use on our phones these days. Another example enabled by networked lighting controls is daylight harvesting. While energy reducing, the greater attraction to many businesses is often having happier and healthier employees. The fact that some customers value non-energy benefits or NEBs more than energy savings is not at all unique to network lighting controls. This is common for many SIP measures, and a good energy efficiency practitioner knows how to tailor their messaging to what is important for each customer. The question also came up around the energy monitoring capability that is built into some NLC systems and whether utilities are using that to measure and verify savings. The presenter commented that while some were, it has not gained widespread acceptance, at least at the time of the seminars. A related question came up around savings persistence, since with NLC systems, customers can easily override or change settings. Presenter suggested that performance-based incentives, which could leverage the energy monitoring capability of NLC systems, are one way to accomplish this. Following each presentation, I asked the audience for feedback on incentive designs and training opportunities. With regard to incentives, the presenter strongly encouraged utilities to support NLC projects through prescriptive incentives rather than custom, which can lead to lengthy engineering reviews. In contrast, prescriptive incentives provide certainty and help streamline the sales process. Currently, most Minnesota utilities offer lighting rebates based on controlled wattage, though Trade Allies in Wisconsin reportedly liked the per square foot basis that was used in Focus on Energy for network lighting controls. With regard to training, audience members generally all nodded their heads when I asked if more training opportunities on NLC were needed. However, I put an asterisk next to this bullet because no contractors were in attendance. I can say that it is my opinion that greater awareness of NLC is needed among trade allies and energy practitioners, not just from the point of learning to install or commission the systems, because manufacturers are already fulfilling this need to some extent, but so they can effectively speak to their customers about NLC opportunities, especially when the customer is considering a possible lighting upgrade. More on this to come. Now on to the meat of the project, which was the case studies. In order to gauge the compatibility of NLC technology with small businesses, we performed case studies of actual projects. The goals were to measure the energy savings, gauge the ease of commissioning, and survey customer satisfaction. Commissioning was a focus because NLC systems are touted as easy to commission, but at the same time, we have heard stories that some contractors struggle with the IT aspects of NLC technology. To measure energy savings, we used data loggers as shown in this picture. To get at the latter two bullets, we performed a standardized interview with each business owner or manager. Here are the 4 sites that were chosen as case studies. We wanted a diverse mix of building types in order to study implementation in different settings. One of the types we initially targeted was healthcare, as we thought a medical or dental clinic would make a great case study. Unfortunately, once COVID hit, this became impossible as clinics locked down to visitors or canceled non-essential spending, so we had to pivot to other building types. In the end, we managed to achieve a good cross-section of building types that are found in small business. Site 1 is a retail building that sells lighting fixtures and home comfort technologies, plus has a large warehouse area that was not part of the NLC system. They purchased an old Shopko building and completely renovated the space. This work was complete at the time of the study, except for the NLC installation. This meant that we weren't able to meter the energy use of the old fixtures, but that comparison would not have been meaningful anyway because the space was completely repurposed. The NLC system included standard ceiling troughers as well as unique application, which was controlling light clouds, which are groups of hanging light fixtures for sale, which you can see in this picture. The NLC system was installed by the business itself, but commissioned by a manufacturer's representative. In choosing an NLC system, the customer was motivated both to reduce energy usage and costs from what the building was using in its former incarnation. The control strategies and energy savings by space type are shown in this table. You can see the layered strategies that were applied in each space. The combination of scheduling and trim was found to produce the highest level of savings, that's for the light clouds, at 49%. Site 2 is a manufacturing facility that produces railroad and train technologies. Its journey to networked lighting controls began with an energy audit that led it to consider lighting upgrades with controls. The facility manager was drawn to the energy savings that the NLC system could provide through automatically shutting off unneeded lights. You can see the control strategies employed in the results table. This facility was unique in that the shipping and receiving area had pre-existing skylights and daylighting controls. Overall, across the facility, we found an average savings from controls of 30%. This system was also commissioned by a manufacturer's representative. Site 3 is an ice arena. They installed a very simple control system as part of a lighting upgrade that consisted of a wireless wall controller with two manually selectable scenes, one with a dimming level of 50% intended for practices and open skating, and one with 100% output for hockey games. Unfortunately, ironically, this site ran into major difficulties in commissioning, which turned out to be unrelated to commissioning, but rather due to faulty and incompatible parts. Initially, the arena manager tried to commission the system with remote assistance, but when the process wasn't working, a technician was dispatched to troubleshoot on site. New parts had to be ordered, but even then the problem wasn't fixed 100%. At the time that post-metering was conducted, 5 or 6 fixtures were not working correctly. They blinked when dimmed. It's possible this affected the savings that were achieved. Site 4 is a locally owned McDonald's franchise. This site was planning a renovation when contacted for the study that included upgrading the dining area lighting and converting an indoor play area to office space. When we explained the benefits of NLC and the incentive offer, they got a bid and decided to purchase the system. Part of their motivation in choosing NLC was a general desire to go digital everywhere, as they put it. Scheduling and trim was used in the dining area while scheduling occupancy sensing and daylight sensing was used in the office space. This area had the highest relative savings. Overall, a savings of 18% for the controls was found for this site. The overall savings achieved at each site are summarized here. There are a few takeaways I wanted to highlight. First, as you can see here, the control savings are small relative to fixture savings. LED retrofits usually achieve savings of 50% or more relative to baseline usage. When controls are installed, the savings are then relative to the energy use of the new fixtures, which has already been cut 50% or more without controls. Second, spaces in which occupancy sensing was used achieved the highest relative savings, with the exception of the light clouds in Site 1. Third, the actual savings that are achieved are highly dependent on site conditions, including the allocation of different space types in the facility, the occupancy patterns, and the specific control settings that are used, for instance, the time delay for occupancy sensors. It is difficult to predict the savings that will be achieved from an NLC system with any certainty based on building type alone. Here the measured savings are compared to the savings factors for NLC in the Minnesota Technical Reference Manual. Note that the study results were relatively close for sites 1 and 2, but much lower in sites 3 and 4. I think these discrepancies simply reinforce the highly site-specific nature of control savings. As part of the interviews with business owners or managers, we asked the participants, what factors were most important to them in choosing NLC. All cited energy savings as an important reason, but from speaking to them, I would characterize this as almost an emotional response, sort of a feeling of confidence that they were not wasting energy by leaving lights on, more than from a quantified ROI perspective. Other factors that were cited as important were incentives, and for Site 4, the ability to monitor the system on their phones. Each of the sites in the study had their NLC system commissioned by an expert technician employed by the manufacturer or a manufacturer's representative. Though at Site 3, the arena, the facility manager initially attempted it himself with remote support. Thus, we didn't encounter the problem of electricians lacking the necessary IT skills to do it themselves. The process was characterized as simple and straightforward at Sites 1, 2, and 4. At all sites, the agent incorporated training in the process, teaching staff how to use the app and add fixtures themselves. I wanted to take a moment to summarize and expand on some of the findings from the case studies. First, as mentioned before, the control savings are small compared to the savings from changing out fixtures. This doesn't mean that NLC are not cost-effective or shouldn't be considered, but it does suggest ways that lighting control opportunities should be presented to customers. First, I would strongly recommend consideration of controls opportunities as part of lighting retrofits. Doing them both at the same time will reduce installation costs, and when the controls cost is rolled up into an overall lighting package, they may be more likely to receive internal approval. Second, and this was not apparent from the case studies, but non-energy benefits should be considered when speaking to customers, as non-energy benefits may be equal to or more important than energy savings. Second, control savings are difficult to predict from building type alone. Sources such as the TRM average together the findings from multiple buildings, so should not be taken as having predictive value for a specific building. However, we did consistently find that occupancy sensing as a strategy produced the highest savings, with the exception of the light clouds, suggesting that energy auditors should look for this opportunity. To close, I'd like to discuss some high-level recommendations as a result of this study. First, Minnesota utilities are well positioned to accelerate the transition to advanced control technologies, including network lighting controls, through their strong relationships with customers and trade allies. Promotion of NLC, like any new and emerging technology, starts with education. It is our experience that many customers and contractors are not familiar with NLC. A big part of education is simply building awareness so opportunities are not missed. Controls companies such as Lutron and RAB offer their own training programs, but utilities can arguably reach a broader audience through ongoing trade ally events. Second, and this is rather basic for anyone who works in energy efficiency, but incentives are important. A properly designed incentive helps to attract customer attention and defray upfront cost. To that end, prescriptive incentives for NLC are recommended, especially to draw in small business participation. Prescriptive incentives are relatively certain as long as the incentive rules are followed, and should require little effort by trade allies or customers to qualify. In contrast, a trade ally may not want to put in the effort to compile the information for a custom incentive, especially for a small business, when the payoff is relatively small and uncertain. This concludes my presentation. Thank you for listening, and I'm happy to take any questions you may have.
Thanks, Joe. That was a great presentation. If you have not already done so, please type any additional questions into the Q&A panel and send them to all panelists. Adoy, do you have any questions for Joe at this point?
Thank you, Marisol, and thank you, Joe, for that presentation. As I wait for questions on the Q&A panel, I wanted to get us started with some initial questions I had. So to start with, Joe, based on your experience, how many customers are interested in extended capabilities?
I would say not very many. Those extended capabilities come at a premium in terms of cost. And it's generally the larger companies, very large facilities that are interested in the capabilities such as heat mapping. That's basically tracking building occupant movement over time, so you can see which buildings or which spaces are being underutilized and which are overutilized. There's examples of large companies such as Google using this capability of network lighting controls, but generally speaking, small to medium, even to larger facilities generally are interested in the more basic control capabilities that come with network lighting controls. However, quite a few do like the ability to monitor the system on their phones, especially, and that's an important aspect, I guess, that should be discussed with customers when they're considering controls.
Thank you for that. A second question I had was, because these savings were so site-specific, what should auditors be looking at for facilities when considering whether to recommend NLC applications?
I think the auditor should start with a general investigation of opportunities for lighting controls in general, such as occupancy sensors, and then daylighting. If there's appear to be spaces where there's potential for multiple control strategies to be implemented at the same time, for example, in offices that on an exterior wall that have windows, obviously they're a good application for both occupancy sensing and daylighting, then that would be a good application for that. Slightly larger facilities that may be interested in monitoring their emergency lighting fixtures too, I think might be a good application for NLC. In general, though, I think just looking for opportunities where there's savings potential from occupancy sensing, spaces with intermittent usage, and then daylighting is another one. When those opportunities coexist in the same spaces, then I think network lighting controls are a good option.
Thanks. A third question I had was, what were successful strategies for getting people to attend these seminars that you conducted?
Yeah, thanks. It was a mixed bag, I guess. We reached our target numbers in terms of total attendance for each seminar. Unfortunately, like I mentioned before, we were not able to get electrical contractors out to the events. But what was successful was working closely with utilities, and I'm really grateful for all the help that we got from the organizations that we partnered with to put on those two seminars. Utility representatives, like I have mentioned, have close relationships with their customers already, so they were able to leverage those relationships to reach out directly to those customers and trade allies to get them to the event. Without the utility support, it would have been very difficult to do it on our own. Franklin Energy is not really a customer-facing organization. We're customer-facing, but we work through utilities. So it's really the utility brand that is well known to customers. So that's really the key to getting folks out to events is utilizing those relationships and that brand that the utility has in their local community.
Thanks for that. The other question I had was, to what extent did the study incentives influence adoption of NLC system by the study participants?
Yeah, so I I would say, with the exception of Site 4, it really didn't influence the adoption. The customers had already made up their minds to pursue networked lighting controls, had already had bids in place. The study incentive was really to get them to agree to meet with us to do the metering as well as the interviews afterward. We actually started out the card grant without a study incentive, and we're finding it was difficult to get attraction. There were customers that were interested in working with us, but it just didn't go anywhere. So working with the department, we were able to reallocate some of our unused funds towards incentives, and once we did that, we definitely got more interest. Site 4, that was the fast food restaurant. They were planning a building renovation that included lighting, but were going with traditional lighting controls until we contacted them, and I came over and did a quick introduction and talked about the capabilities that network lighting controls could offer them, and then of course informed them of the incentive. And at that point, they were very interested. So I would say in that instance, yes, it did influence them to choose network lighting controls. But for the others, no.
Thank you.
I don't see any questions in the Q&A at this point, but there is a question, Adoy, that maybe you can answer in the chat, which is that whether or not network lighting controls is going to be on the table as a technology to be evaluated for inclusion in the next TRM. And Joe, you may have addressed this too. I think you said that it already is in the TRM. Am I wrong?
That's correct. Yes, it's in the current version, which is 3.2.
Okay. And Adoy, do you know of any plans to reevaluate the network lighting control in the TRM now?
I do not know of any specific plans.
Okay.
The TRM Advisory Committee will finally decide on what needs to be updated. So that process would be starting pretty soon.
Okay, great. And I don't see any further questions. Or
Oh,
do you have
no,
one?
I now see them.
Okay, great.
So there's this one question which says, do you see any potential for the use of off-the-shelf type smart lighting, like smart bulbs from big box stores? And how might those savings compare to a contractor installed network lighting setup?
Yeah, I do see potential for those. I think that could be a cost-effective solution in many cases. And commercial lighting fixtures are already available with integrated sensors, and there are varieties that do both occupancy and daylight sensing. So that could be a good solution for smaller customers, especially because there is a cost premium with networked lighting controls. That can be a barrier for some customers. So yeah, short answer is yes. I think there is potential there.
Thanks. I also have one more question. The question is, in many new construction projects, I've seen very different approach to reach some of the same energy savings goals. So a trend towards fixtures that have an occupancy sensor and sometimes even a photo sensor built in. Could you discuss the pros and cons of NLC versus sensors with each fixture and where you expect for trends?
Yeah, well, fixtures that have sensors built into them could be part of a networked lighting control system. They wouldn't necessarily have to be, though. But when they have sensors built in, that allows, and I'll throw out another buzzword here, luminaire level lighting control, or LLLC. And that's been a growing area of interest in the lighting and utility industries. Studies have been done on that recently, and in general, LLLC has been shown to lead to the highest energy savings as opposed to zoning approaches where one sensor might control a group of fixtures. So I think they're really part and parcel of the same thing. The question is just whether they are linked to a network that can be accessed like on a smartphone or on a PC to monitor and adjust the system. But yes, it's definitely a good technology that is being seen in new construction. Basically, the energy codes require a great deal of lighting controls in them, and one way that can be accomplished is with network lighting controls.
Thanks for that. Mary-Sue, did you have any more questions in the chat?
Yes, I have one more question in the chat. It's how do you see NLC or LLC controls being most useful in the return to office post-pandemic planning?
No, that's a great question. I see them as being more useful than ever, actually, because many offices now, many businesses have gone to a part-time office schedule where workers are required to come in maybe once or twice a week, otherwise are allowed to work remotely. So that means there's going to be, unless the business has downsized the space, that means that there's going to be a lot more rooms with longer periods of vacancy. So I think network lighting controls are more important than ever, and there's also more opportunities for integrated lighting controls, like I discussed before, where a ventilation can be turned off when not needed in a space. So there's definitely this whole return to work post-pandemic has opened up even more opportunities for lighting controls and other building controls to deal with the variable occupancy.
Thanks, Joe. I don't see any questions in the Q&A panel.
Yes, I don't see any more questions in the chat either. So thank you very much, Joe,
Yes,
for
thank
that
you.
presentation and for your responses to the Q&A. And thanks, Adoy, for facilitating the Q&A. If you have any follow-up questions about this card project, please feel free to reach out to one of us. The recording of this webinar and the slide set will both be available on the department's website in a few weeks, and the final report in a couple of months. When available, you can link to either of these from the quick links on our Applied Research and Development webpage, as indicated on this slide. The department R&D page has a lot of other additional resources and information that are related to the CARD program and to CARD research projects, which you can check out by going to the address that's at the bottom of this slide. Thanks for your participation today. We appreciate your interest in CARD projects, and I want to take a few minutes here just to mention 2 more upcoming CARD webinars. On June 8th, Slipstream will explore using the lens and framework of SIP to understand energy issues related to food sovereignty and resilience in Indigenous communities in Minnesota. On July 13th, the Citizens Utility Board of Minnesota will present their results on a study that focused on identifying improvements to energy and efficiency program design in order to increase energy savings of underserved populations. You can keep abreast of upcoming webinars and other news related to the Conservation Improvement Program by signing up for our SIP updates on our email list. You can link to that on the slide, on the link that's on this slide. And in the meantime, contact me if you have questions or suggestions about the CARD program. And as a final reminder, there'll be a short evaluation that launches after this webinar. Please take a few minutes to fill it in and let us know how we did. Thanks. Have a great rest of your day.